Okay, so what we're going to do now is set up the VMware tools, and what this allows us to do is make this screen full size. Currently it's not, it's just a window inside of the VMware player. But if we do install the VMware tools, we can tend to make terminals and things of that nature full screened. And it also allows other things like being able to drag and drop files between two different operating systems, the host operating system and the VMware virtualized operating system. So for that reason, it allows for some extra functionality to make life easier, and just better as it fully integrates the two. Well, as much as possible anyways. How do we access this? Well, basically if we click the CD-ROM player here, we can tell it to connect at that point in time, in which case then it'll pop up and ask you to click on here to see the files, and a little pop-up will appear down here on Fedora 17. Do so, and the window pops up, and we get something like this right here. Now, what I'm going to do is drag and drop this right off of here and into my home directory in a place where I'm going to want it. So it would make sense to have this set up like so. And right now it's coming up as VMware Tools. I'm just going to call it a special folder inside of the home called just VMware. So I'm just going to right click on here, say create a new folder. I'm just going to call it VMware, like that. I could just do it all lowercase if I prefer, you know, VMware. It just doesn't matter. It's just whatever. But whatever you want to do. Okay. So with that, we're going to need to drag and drop these files over. I'll just go ahead and grab the manifest too while I'm at it, just for the heck of it. And we're going to drop into home because it's not making the folder here appear that we need, and then we're going to select them again and drag and drop them into VMware. Unfortunately, I would just display it directly in here, but it didn't list the folder. So anyways, inside of the VMware now, I don't care about what's this right here. As far as the CD-ROM goes, we can disconnect it at this point. It really doesn't matter now. I need to unzip this. I can do this a couple different ways. One of the ways I can do it is simply just by right-clicking on it, coming in here to Arc or Arc Manager, and click on it like so. And I can just tell it to extract. And it is extracting out that file. The other way to do this is to do a tar-gz unzip file setup, and this will unzip it command line. So there's two different ways to do this, and there's the folder right here now. Essentially we did the same thing, but we did it graphically. Let me show you how to do it non-graphically, just to show you there's a couple of different ways to do this. That was the graphical method. Oh yeah, by the way, you can't hit the delete key and actually make things delete now. In Fedora 17, they changed that. Now you actually have to move it to the trash can, since you're now unable to delete files or folders or anything of the sort. I find this feature really annoying, but that's me. Used to be able to just hit the delete key and delete something, but not anymore. Alright, so I'm just going to bring up the terminal like this right here. And it's going to launch me right into my home directory. And right here we see a VMware folder. Of course, I could have done mkdir VMware in order to make that folder, but I didn't. I did it graphically. VMware. Like so. ls into it. We can see it now. Cool. Then I'm going to type in tar and then Z, X, V, and F. The Z is for unzip, X is for extract, V is for verbose, make it visual, and F is to create the folder. I could type this whole thing, but I'm lazy, I'm not going to. So what I'm going to do is I'm just going to come up here and just copy and paste it, like so. And basically what I did is I selected that, and then I middle clicked, and it pasted in what it was I would have typed, and basically hit the enter key too for me. Because I did the line beyond the selection, it made it act like hitting the enter key. If I hadn't have done that, and I got just right up to the actual selection of the word itself, and then middle clicked, I would have then had to have hit enter key afterwards. But I didn't want to, so I just let it make it do it for me. Alright, so with that, I'm going to CD into the VMware. I could type the whole thing, or I could just hit the tab key and have it fill out the rest for me, like that. ls, and here we are inside of this whole setup. Now, one of the things we need to do is read what it is it wants us to do. Now, I could do that, or I could just execute this VMware-install-.pl and then follow the instructions as it says. One of the things, though, it needs, and I know this ahead of time, is that I know that it needs to have, hold on a second, let me pull up the installer. Add remove software. I just typed in install for the search thing here and have it pull it up. One of the things it needs is it absolutely needs the source code to the Linux kernel. And if you don't have source code installed, it's not going to work. The reason why is because it needs to actually generate a software module, aka a driver, to work in here. And so it has to have the source code of the Linux kernel in order to generate that driver. So we need to worry about that. So let's type in kernel and pull up. And remember, the kernel is the core of the operating system. So we'll need to pull up the kernel here so that we can compile that. Make sure we have the kernel source code installed first off, so that it can be compiled down. And we're just waiting on it to find stuff. It's querying right now. So that's where a little message just pop up here in the corner and let you know what's going on. And help let you get this set up. Alright, so the kernel, as it says, yep. And we got a couple different ones here. Kernel compile with debugging, and so on and so forth. We can just check these and turn these on, etc. You can turn on and install several of these. It really doesn't matter too much. So I'm just telling it the kernel development. That's what I want, because it's going to give me the source code. Documentation is always fine. I don't have a problem with that, that's for sure. I'm just grabbing these different ones here so that we have and all these match. And of course, I have to be running in the same kernel. I'd like to point that out as what I'm running in currently right now. So you're probably wondering, well, how do I know what kernel I have? Well, there's actually a way to find that out. If I type in monitor, system monitor, unfortunately, I have two applications that are named the same and look the same, but they're not the same. I believe the second one there is the one I'm looking for. Let's find out. And yeah, more or less. It used to be that it would actually have a whole splash screen on here that would tell you what kernel you have, and apparently they no longer have that. And that's really just too bad, because that was really useful, actually. That's very unfortunate. Let's see if there's anything. Nope. They apparently no longer have that. How wonderful. System monitor. Please tell me I don't have two of the exact same program. Okay. Okay, so this is the one I was looking for right here, and apparently that's the other one. Alright, but if I go over to system, bam, it pops up and it tells me all about it. And it tells me my current kernel is 3.4.4-5. So click around till it pops up the proper system monitor program that you're looking for. It's just frustrating, but you'll find what you're looking for. And check it out, that's a match right here, 17, and that's exactly what we have too. Awesome. So that's what we're looking for. And basically we have selected the magical ones that we needed here. I could go through here and search some more for the stuff. Granted, I could even type in the actual version number I'm looking for, and then it would give me just that version and nothing else, which is also nice. I'm just going through here and just making sure I don't have anything else that I need to be real particularly interested in. Alright, what was that VMware thing I just saw? Looks like I'm going to go with kernel. because that would be nice if it just happened to have it already pre-compiled and ready to go. Swear to solid. So these are analysis tools, which is great if you're dealing with crashes, particularly if you're developing kernel stuff. Otherwise, you're probably not going to care so much. Could give you some useful information. Alright, well, I guess as I was flying by, I thought I saw it, but maybe I didn't. Well, that would have been useful. It would have saved us this whole process. Probably saw the Vim there and got mixed up with that. Yeah. Okay, well, good to know. Mine was playing tricks on me. Okay. Kernel modules to match. Sure. PAE capable machines. Sure. Let's go ahead and do this. We're actually running the PAE version of it, so yeah, by all means, let's just grab all that stuff. I got some other stuff here. I don't know if I care about the rest of this, but I think that was useful though, what we just grabbed. Alright, so that gives us the source code in place here. And it is with our current version of our kernel, so we don't have to worry about having to restart and run another kernel. It is going to ask me for my password. Now granted, I could have done this through Yum, but then I would have to have known these packages off the top of my head, and I don't. So I do know I want the kernel, but I don't know what kernel ones for what. So it's useful to be able to come in here and graphically select what I'm looking for, more or less, and search through it like this and download what I'm looking for. And there's literally hundreds of thousands, if not millions, of applications that are free open source on the Linux installer here. And we can add additional repositories, basically additional software lists of extra programs beyond what's listed here too. So there's a number of things that would allow you to get all that going and whatnot. But as you can see right now, it says it's downloading the packages. And so that gets the downloading going for the download installs. This is a great exercise because it lets us combine a couple things. You got to learn about tar and unzip, all that things. The GZ is a zip format. Tar is like an archive format, so you can actually combine the two. So the tar basically is like a one file container folder, but it's not compressed. So when you GZ it, you compress it. And GZ is not a bad format. There's other formats you could use. You could use BZ2. You could use like bunzip2. That kind of thing, and bzip too. So zip it up for those commands and whatnot. And the other thing you can do is 7z with your tar or whatnot, so you could do that too. And 7z is a great format. In fact, it's probably the best one out of the three. It's just not as popular for, I don't know why, but it is a very popular program for unzipping. Also, if you want to be able to play videos or anything like that, try out VLC Player. It's great for playing videos. And there's a number of video formats and codecs you can install that let you play videos readily in here. Of course, OGG format is the native format for playing videos, OGG formats. It's built into Linux. Fedora has quite a few features, and this Red Hat has been around for a very long time. Actually, one of the top three, the third person in command of Linux, was the president of Red Hat back when. So he ran things, and so he was part of Red Hat. So Red Hat's been a big distribution of Linux for quite a long time, actually, now, and they were they're probably the first ones really to bring a easy to install, relatively speaking, easy to install with graphical support and setup. So they were the first ones to really have a good distribution of Linux going. And I don't really think at the time, back when, there was really anyone else that could honestly compete with them early on in the early days of Linux. Back closer to, well, right after they added 3D graphic card support, because prior to that they only had about 10-15 cards supported, and so yeah, they had X Windows, but no one really used it. Things got a little interesting when they had KDE around Red Hat. It used to be called Red Hat before. It was called Fedora and Red Hat Enterprise. It used to be called Red Hat. Around Red Hat 5.2 is when they had KDE come out, and then they had GNOME 1.0 release, where it really, was definitely right on par with Windows, if not more so, on the graphical and user interface. And that happened on Red Hat 6.0 with GNOME. That's when GNOME 1.0 came out, and they had a lot of graphical card supports there. And so, yeah, it has made a big difference. They used to do like 5.0, 5.1, 5.2, etc. Now life is so much easier. Used to we had to go hunt down all these RPMs and install them. Now we can use Yum, Yellow Dog Update Manager. It's not developed by Red Hat, but Red Hat did come up with the RPM system, and the RPM system is Red Hat Package Management System. And essentially what's going on here is with Yum, it goes in and finds all the supporting RPMs that are needed in order to make this other RPM install. This is like a whole check and balance system. There have been other systems in the past, but Yum's the best one for RPMs. Back when there was Red Carpet, it was like really the first actual real effort to create a whole repository of RPMs with the checks and balances for installing them. Used to have to go in and download all the RPMs individually until you worked out all the dependencies for every single RPM, because you would download the RPMs. You can still do this, don't do it, but you can, unless you absolutely have to. But if you try to do it without Yum, what you'll have to do is you'll have to download the RPMs for what it is you want to install, and then you have to download those RPMs, supported RPMs, meaning that you have to have the RPM you want to install requires certain RPMs to be installed for it to work. So you download those RPMs, but then those RPMs have their own dependencies where you have to have these RPMs to work. And so you have to download those RPMs and so on and so forth until you get all the RPMs downloaded that you need. And then you hope that none of them conflict with any other RPMs you already have installed in the system. Yum is doing all that stuff for us automatically. So basically, it's doing all that. It's going out, finding all those RPMs, going out, working out all those dependency checks, making sure it doesn't conflict with any of the other RPMs installed on the system, downloading them all, and installing them. And that's what it's doing right now. It's installing all these packages. Cool thing about Linux, though, is after you install these RPMs, they're live on the system immediately. You don't have to restart your computer or whatnot, unless you're updating the kernel. That's a different case, and the reason why that is, and it's true for any operating system, is because that's the core of your operating system, where it's actually running your hardware and whatnot, and doing the low-end tasks. So you can't just swap out what is literally running your entire system, because if you do, your whole system will cease to run, basically. So that's why you do have to restart in order to select a different kernel for it to come up as a whole running system. So yeah, if you do update your kernel, yes, you are going to have to restart in order to use the new kernel. That's a fact on any operating system, period. But that's basically what's going on there. Alright, so it's doing our install. There is two different installation systems out there. There's RPM and there's Debian. RPM is going to be your Red Hat package management. A lot of more of your cutting edge, latest, greatest stuff is done as an RPM, because they don't really have to go through a whole big consortium of checks and balances to see if whether or not they're allowed to have their software package integrated in with the other software. That's what Debian does, and that's what the big deal about Debian package management system, or app-get. Instead of Yum, they use app-get. You can actually put app-get on Linux too, believe it or not, on Red Hat. I'm sorry, it is Linux, but on Red Hat RPM system. So you don't have to use Yum if you don't want to. You can actually use apt. I'm not going to get into how to do that right now, but there is a way to do that. But essentially, what it does is it's already, really all the problems are worked out type thing. I'd say better than Yum is worked out. Yum is pretty good, but I'd say app-get does a better job working it out. But the thing about RPMs is, if you want the latest, greatest, newest software, RPM is the way to go for getting the latest software updates and everything. But then you run the only thing about it on the negative side is that you don't get all the smoothness, and you don't get it worked out like they do on the Debian system. Where Debian system goes, we're going to make sure there's not problems, and there's no issues coming down. And Yum, sometimes, rarely, you'll run into issues where they didn't work out the software working with each other, installing together properly. So it totally depends. Both systems are very popular, and both systems are used heavily. Both systems are very good, and I would recommend either one as far as that goes. So it really just comes down to a preference at this point in time. Debian's been the oldest one around for having a working software package management system on Linux, and their system has worked very well for the longest I can remember. Since the early days of Linux. So while they were just trying to get the RPMs as a replacement to the tar systems, tar GZ, that's how they used to do it on Unix, is tar GZ, like we just unzipped here on this whole VMware tools thing. Just like we just did there, you can do the same thing on Unix, and then you would have to, in the early days of Linux, you'd have to download your tars, unzip them. You wouldn't have RPMs. You'd have to compile your own software, generate a program, and hand install that program. And it was a lot of work, because not always would the compiling programs be very good. So you go to compile XYZ thing, and it wouldn't compile on your system, and that's quite common. And then you would end up with people who would just release programs full of bugs on their compiled system, and so they wouldn't compile, and you'd have to go through and fix their software, actually be a programmer and go through and actually fix their code. It was a lot of work to get a program running at times. So RPMs and Debians fixed all of that, all those headaches and all those problems for us, and that's why they went to RPMs and Debian installation systems, app-get systems. And app-get was the first actual package management system for Linux for installations and whatnot. And it is awesome. It's easy to update. You just say update, just like we can in Yum. We can just say Yum space update, and it updates the whole system. Just like in Debian, you would say app-get space update and update the whole system. So really quite nice. Okay, enough of that little history lesson. And why we're using what and how it came about. Let's look at actually running the script. So .pl is going to be your Perl script, and we're going to execute this at this point. So I'm going to say VMware. I'm going to run this as root. So I'm going to do su-dash here. I'm going to say password. You might be wondering why. Well, if I'm doing installation, I'm doing kernel things of that nature, whatnot, I really do want to run this as root because I won't have permission to do some of this stuff otherwise. So for that reason, I need to run it as root. I'm too lazy to type all that, so I'll just hit tab in order to have it fill it out for me. I'm just going to hit enter. Of course, I could have selected it and hit middle click and pasted it too. And that would have worked. If it asks you if you want to put in one of these directories, I don't have to actually type it in if it gives me a suggestion. I can just say enter, and it will do its suggestion. So I'm going to be lazy. I'm just going to hit enter over and over again. Actually, you may want to refer to it as efficient, but whatever. Same stuff, really. Alright, so we're saying enter to all those directories there. And path usr/lib/VMwareTools does not exist currently. This program is going to create it. Well, yes, you want to create it, otherwise you're not going to be doing anything, right? If that folder doesn't exist, you can't put the files in it. So, yeah, we do want to create it. Kind of surprised they even asked me. Whatever. So it's going through, it's doing its thing. We're telling it to keep creating these folders. Do I want to make a folder so it can contain the files? Yes, I do. Of course I do. Before running VMware Tools for the first time, you need to configure it by invoking the following commands. Do you want this program to invoke the command? Yes, otherwise it's not going to work. Experimental VMware File System Sync Driver. This is a new feature that creates backups of the virtual machines. Please refer to the VMware knowledge base for more details on this capability. Do you wish to enable this feature? No, I don't, because I don't want to run anything experimental because it tends to make things crash. Do I want to go to GCC? Yes, I do. So would I like to change it? No, I would not. Stay with the default on that. Okay, searching for a valid kernel header path. Detect kernel headers at. So, oh, gee, it found the kernel headers we installed earlier just a second ago. Path lib modules, blah, 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 appears to be a valid path. Would you like to change it? No, we would not. So that's why we just did that whole install earlier. Now it's going to go through and it's going to find all this code. It's going to compile it. See, the .o files is where it's actually compiling down the C object-oriented code into binary, but it has an intermediary step, basically a middle step, where it's compiling the code down to byte code before it converts it down into assembly code at ones and zero level. So it's like a in-between step where it translates it from a human readable code down to ones and zeros, and that's what your .o files are, and they can be removed on a cleanup operation inside a make system. Anyways, that all said, the module VM next already installed. Override, awesome. VMware guest system allows to share folders between the OS and your workstation. Do you wish to enable this feature? Yes, you do. So this means you can drag and drop files from your Windows onto your Linux, or from, if you're running this inside of Linux, from your Linux host operating system into your Linux, or say you're running on a Mac, you can drag and drop it from your Mac into your Linux, whatever. From your Linux into your Mac, whatever. You go back and forth easily between the two. To have share folders features, you can install the driver by running VMwareTools. Again, after making sure the GCC VMtools make the kernel sources for your running kernel are installed on your machine. These packages are available on your distribution CD. Press enter to continue. Yay! Alright. The Fast Network Device Driver module is used only for our fast network interface. Yes, the rest of the software provided by VMwareTools is designed to work independently of this feature. If you wish to have this fast network driver enabled, you can install the driver by running VMwareTools.pl again after making sure the GCC VMtools are all in place and whatnot. Okay. Automatic kernel modules are experimental. I don't want to find out what happens. So it didn't build some of the kernel modules we wanted, like the fast network connection, which would have been nice. And it would have been nice to be able to drag and drop the files between two operating systems, but it failed to build those kernel modules for whatever reason. I mean, we could look at it here. Really didn't give me a reason for it, other than it said maybe I didn't have everything that it needed for compiling it installed. So we can go back and do that. So it wants GCC and binutils make and the kernel sources for your kernel running kernel. Well, we did install the kernel sources, so obviously that's not the problem. But the problem is maybe we don't have binutils and some of those other programs that it needs. So we might go back and take care of that, as that's probably a good idea. It's creating a new init.rd boot image, which is absolutely required for booting on a kernel. And essentially it's compiling a new kernel setup here. Okay. And it is finished. Now, one of the things I want to do is it threw a fit about a few things I didn't have in place, and binutils was one of them. So let's see if we're missing it. And it says no, we have it installed. Now we do have GCC installed too. We haven't installed GCC because it was able to find it. So obviously that's installed too. Okay. So besides that, we need the make and the kernel source achievement Christmas. So we only have make left. I can't imagine not having that. So I really don't see how it would be able to. Okay, so everything it said it needed, we had, and it still didn't work. So Hopefully it works for you. It didn't work for me for compiling that. Maybe they have some issue running, and maybe we haven't been told the whole story of what it is we need beyond what they told us. So we had everything that they told us we needed, and they outflat. Yeah, because we have just basically verified that we had all this right here, which is all the things that said we needed to compile that module here. And it didn't compile, and it didn't give us an error as to why it didn't compile, and they're not telling us what we need in order to make it work. So sounds like they have a code mistake in the actual module. Just reading this. So because yeah, on the C file here on line 2599, 48 characters over on that line is an error with incompatible types when assigning to type struct anonymous. So they have a code mistake, an error in their code for that module. So that's why it didn't compile and it errored out. Which there's nothing we can do about that. They need to fix their code. And yeah, that's just what the deal is. Wow. And then on this one, got a warning without casting an integer. So it's treating the warning as an error, and then so it's just not going to compile because they want it to be very strict for the compiling. And it's basically they are not treating their data types correctly. Again, same kind of thing as like the other error. Assign a machine pointer to an integer, that has to be an unsigned long int if you're going to do that. Otherwise, it can be, yeah, I don't blame it if they're throwing a warning about that. That's bad programming if you not. Anyways, yeah. Yeah, if you ever do move a pointer to an integer, make sure it's a long unsigned int, because it's the only thing big enough to hold that. It's basically the same data type, but it's retyped when you go to a pointer. Anyways, I'm not going to get into how to do that kind of programming in this. It's way above what we're doing. Anyways, so there we are. It's installed now, and we'll probably have to restart the system for this to take effect. Because if I just full screen it right now, it's not going to actually full screen. But I do need to restart the system at this point. So a couple ways I could do this. I could just exit all these windows and then do it. The other way I can do it is, just kind of do it heavy-handed here and just go shut down like that. And if you do a -H here, it's going to be halt, which means shut down completely, and just turn off the power on the system. If you hit R, it's going to restart. Now I can tell it when I need to. And this is really great from an administrative standpoint for network. Maybe you need to restart the servers at a certain time or whatever at night. You can do that. You can say shutdown space -R for restart, right? And then space, and then what time you want to restart. In this case, I'm saying now because I want to restart now and not later on. You could also have it say in 10 minutes, and then you even input a message where it goes out to all the client machines, and then everyone sees that, oh, the server's going to restart in like 10 minutes. And let them say, so back up your work now, blah, 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 and warn everyone. So you can do that. It's really cool in Linux. And it's a shutdown command here does that. So I'm just going to use shutdown space -R space now to restart the computer right now. Well, this virtual machine anyways. And so there it goes. Okay. So I could do the PAE one, which is what I was using and working with. So why not stay with it, right? We had the source code, it installed, it compiled. We actually built the kernel for that one, so we need to stick with that one. There were some other options there, but again, we did not build the VMware kernel module for those. So because we didn't build the VMware kernel module for those particular kernels, then we wouldn't get the VMware benefits. So we'd have to go through that whole process again for the other kernels with their kernel modules and whatnot for the VMware in order to make them viable for VMware. Okay, just give it a moment. Bam, there it goes. And this should enable some features that we didn't normally have otherwise. And you should be able to full screen after this, which should be great. Certainly worked on CentOS too. Same process you use for doing that. Okay. Alrighty then. Let's see here. We have password, like so, and we're going into the system. I think it's going to take. Just give it a moment, and it is full screen now. Awesome. We're done. That was it. And that is how you set full screen. And it also showed you how to, well, so we covered several things. Not only did we get the VMware tools working here on Linux so that we can actually full screen and add some additional available functionality and compatibilities between the host system and the Linux system, the virtual machine, and allow for some extra capabilities there. But besides the fact that we did that, we also have taught basically how to install extra kernel sources and building tools that are needed for compiling parts of the kernel, and how to create a driver, how to go about running and executing a script to build out those kernel modules from the program, and here in this case it's VMware Tools, how to unzip a tar file, tar.gz file to be more accurate, and how to execute that, how to access the CD-ROM software for the download for the updates from VMware. The way we did that is by clicking on the CD-ROM, and basically how to do all this stuff through command line, and how to install packages and hunt them down, find them, etc. So this really covered a number of topics that were really useful, and this basically allows us now to full screen our whole Linux, and it now takes up the entire monitor and not just this little piece that's being recorded here. So with that, my name is Nate Nestler, and this was for how to set up VMware tools on Red Hat Fedora 17. Thank you very much.